Wave 54 identifies one of those intermolecular attractive forces that we've been talking about so much, and it's called hydrogen bonding. You remember that the stronger the intermolecular attractive force between molecules in a substance, the harder it is to boil and the more energy it takes, so it's going to have a higher boiling point. If the glue holding these molecules together is very strong, then it's going to take more energy and a higher boiling point to break that glue apart and cause the particles to vaporize. So, if you recall, hydrogen bonding occurs in water primarily because it's a polar molecule. Note that there's a partial negative charge on the oxygen, indicated by blue here, and there's a partial positive charge on hydrogen. And that oppositely charged particle is going to cause water to cling to itself so that the negative oxygen is going to be attracted to the positive hydrogen. And this goes on on the molecular level within water. Basically, the negative will be attracted to the positive and vice versa. And this type of intermolecular attraction is called hydrogen bonding. And remember, it's this IMAF that contributes to water's high boiling point. That's the key here. The stronger the intermolecular attractive force, the higher the boiling point. And this not only happens for water, but it also happens for all polar molecules. And if you remember, polar molecules can be assessed by the difference in electronegativity between two nonmetals within a molecule. So let's try some problems that deal with this idea. Which term represents an intermolecular force in a sample of water? You should gather that the intermolecular force present in water is called hydrogen bonding. Please note that 2, 3, and 4 are all examples of intramolecular forces. Basically, these are happening within the molecule. Covalent bonding is happening between atoms within the molecule, not between molecules. Metallic bonding also occurs, is another intramolecular force of attraction. So is ionic bonding. Hydrogen bonding is the only intermolecular force within the sample of water. Which compound has the strongest hydrogen bonding at STP? It's important to note that the substances that have a high degree of polarity are going to have the highest degree of hydrogen bonding. So if you take the electronegativity difference between these molecules, you'll find that the highest difference occurs between O and H. As a result, the degree of polarity is quite high in choice 1 compared to the other choices. Therefore, hydrogen bonding will be strongest in water because oxygen has a high electronegativity and is covalently bound to the hydrogen, which has a lower electronegativity and a small radius. Therefore, the degree of polarity will be quite high in water compared to the other substances. At standard pressure, water has unusual properties that are due to both its molecular structure and intermolecular forces. For example, although most liquids contract when they freeze, water expands, making ice less dense than liquid water. Water has a much higher boiling point than most other molecular compounds having a similar gram formula mass. State the type of intermolecular force responsible for the unusual boiling point of water at standard pressure. To get full credit for this problem, all you have to state is hydrogen bonding, H bonding, or sometimes called dipole-dipole interactions. A dipole is just simply another word for a polar molecule, which is, in the case water, it has a negative and a positive side. At standard pressure, CH4 boils at 112 Kelvin and H2O boils at 373 Kelvin. What accounts for the higher boiling point of H2O at standard pressure? If you chose answer choice 3, you got it correct. But I want you to note that water is one of those polar molecules that we've studied, and CH4 is a non-polar substance. And I want you to look at the difference in boiling point between these two substances. Water's hydrogen bonding is so strong that it takes such a high degree of heat in order to get water to boil, compared with the nonpolar molecule within methane. It only takes 112 Kelvin for methane to boil compared to water. So the intermolecular force of attraction is so strong in water that it takes such a high degree of heat and energy in order to get water to boil compared to the nonpolar substances. And this is actually true for polar substances compared to nonpolar substances. Polar substances tend to have a high degree of hydrogen bonding and therefore have a higher boiling point. Okay, so when it comes to evaluating problems that involve strong intermolecular forces of attraction, please note that when it comes to water, the reason why its boiling point is so high is because of that intermolecular attractive force. What is the name of that intermolecular attractive force? It's called hydrogen bonding, where the H forms a partial bond between the oxygen because they're oppositely charged. Hydrogen has a partial positive charge, oxygen has a partial negative charge. And it's that glue that holds water together and requires a high degree of energy in order to get water to boil. Thank you for watching.